All right, welcome back, everybody. Thank you for standing by for those technical difficulties we had, but we're all set now, and I'd like to present the final team for check-in today. It's Team 5803 Apex Robotics, and they're from SeaTac, Washington. Guys, why don't you introduce yourselves?
Hey everybody, how y'all doing? I'm Evan Morrison. I'm one of the lead mentors on Apex Robotics. With me, I've got Jonathan Schaefer. He's one of our team captains, and back again this week is Maura. She's our lead programmer.
All right, well, welcome back, guys. Thank you for joining us once again. So let's talk a little bit about, like we have with everybody else, let's talk about the strategy. Last week, you guys had some pretty firm ideas as to what your strategy was probably going to be. So let's kind of briefly go over that and tell us what your plan for your robot is this season.
So for strategy, a couple of broad things. We're going for auto this year. We're going for scoring balls and going for gears as well. We're looking to shoot from a couple of different positions, and we're also looking to be scoring gears. So that's just a basic idea of what we're looking to accomplish this year, but we've got some pretty ambitious goals.
Yeah, I was going to say, so last year you guys, this is your second year as a team, and last year you guys went for this year, the way you describe it, it seems like you're going to do all the things. Last year, you guys definitely compromised and decided to only go for the low goal. What led you guys to sort of change that motif and go for the bro time?
Well, I mean, we have a lot more resources this year. We've got some new mentors from some very awesome companies that have helped us out, and other teams have been very generous to us. So we're kind of seeing how well we can do and pursuing the peak of excellence.
There you go.
Yeah, we're setting our sights a little bit higher this year. I think last year, with a brand new team, we didn't have any students with any experience on it. This year we have that. We didn't graduate any seniors last year, so we've got a whole crop of students who have 1 year of experience under their belt. And as Schaefer mentioned, we have C4 Labs down in Tacoma is a laser cutting and fabrication shop, and they're letting us go down there and use their CNC mill this year, as well as Bare Metal 2046, one of the local teams, is going to cut some box tubing for us. So we've got a little bit more resources and a lot more experience.
Very cool. All right, so let's kind of talk a little bit about sort of those resources and how you're using them to prototype. So in your video, we saw a lot of different things, a lot of drills involved. Maura, do you want to go on about that a little bit? Tell us about what you guys use to prototype and how you go about it.
Well, we just used the materials that we have provided. So pretty much a lot of wood and mostly drills. But we kind of, before we prototyped, we kind of split into our groups of what we wanted to do: gear, fuel tank, and shooter. And also intake, right?
Yeah, we did a little bit of intake prototyping.
Okay, cool. So we saw in there that there's a it seemed very it seems like you guys obviously work out of a classroom, so you don't have ready access to mills or lathes or routers or what have you. So a lot of the stuff looked, I don't want to say jerry-rigged, has kind of a negative connotation to it, right? But it's a little more maker, we'll say. How does that sound? Why don't you guys go into that and how you guys work with the resources you have available to prototype what you want to do?
Yeah, so we're, as you can see, of course, we're using a lot of wood, cardboard, just anything that's readily available, as well as some parts from our off-season. We have a test bed that we're calling Party Stalker, and it's basically, Party Parrot was our off-season project, and we've taken the base from that and we're repurposing it as kind of a prototype build. So we're just using everything we have available to the greatest extent we can, and that includes drills and all kinds of rollers and wheels we have left over.
So I kind of too. One thing that I really like doing is taking gussets and screwing it into wood pieces, just to give some solid bearing mounts and things. And so that combination has worked really well for us.
Cool. So I kind of want to talk a little bit more about that, about how you're using your off-season robot. But can we explain Party Stalker what the name? It sounds a little weird.
Sure.
Uh,
Yeah. Well,
You
so
do it.
so for those of you who've been around for a couple years, you may have remember Team 254 put out a video in 2014 about week 3 with a robot that they called Skystalker, which was essentially a jerry-rigged wood and some metal mock-up of what would become Barrage, their competition robot, and it was just wood and simple materials that teams had found. The team had just whipped up this robot from on top of an old drive base, and they were driving around the field and actually running match cycles with it. And so we it's a portmanteau, right? We've got Party Parrot was the old robot. We took it apart and we appended Stalker onto the end in homage of Sky Stalker. So it sounds a little bit weird, but the name stuck.
Yes. Okay. All right. That makes it a lot less peculiar. So before we talk about the how you guys are using that, I want to remind everybody who's watching live, if you've got questions for these guys, type them into the Twitch chat with !Q, then your question. And if we like your question, it'll get pulled in automatically, and we'll ask these guys toward the end of the show. So we saw there, I think it looked like what was a shooter from Party Parrot or Party Stalker. I assume it was because there was some beautiful CNC plates, which sound like something that you wouldn't be doing during a prototyping phase. How do you guys utilize that, and what were you using it for exactly?
Yeah, sure. So we were prototyping a few different designs of a shooter mechanism, and one of the ones we ended up prototyping was a linear shooter, which we already kind of had with Party Parrot. So we straight up ripped it off of the robot and hooked it up
Gently.
Well, yes, gently and carefully, of course. And we took it. We added some shims to make sure that, or to transform it into the size of the new balls, or the fuel, I should say. And we just started shooting it, and it performed pretty well for something that was not designed originally for the wiffle balls.
Cool. Well, let's talk a little bit more about the results from those shooting, the shooting that you've done. So we saw a couple of videos, or a couple of shots in the video. One of them looked like a lot of balls missed the target, but they looked
Yes.
fairly in line with each other. Do you want to go on about that a little bit and tell us what you've learned?
Yeah, I'll talk a little bit about the shooter prototypes. I was kind of in charge of the shooter group, the mentor in charge of the shooter group. So we kind of had 2 prototypes. We had what we call the hooded shooter, which is somebody just dropped some aluminum in the other room. We had the hooded shooter, which is a piece of just curved plastic with some grip material on the back. And that's kind of your basic flywheel shooter with a curved hood. And so we'd prop that at different angles. And then we had the Party Parrot shooter, which is the kind of 2-stage linear shooter where you've got 2 wheels and a flat plate behind it. And we ran both of those off of one sim, 1-to-1 gearing. So they're roughly the same, both of them using 4-inch Coulson wheels. So we're trying to change as little variables as we could between the two. We had mixed results. We don't have any control loops on them yet, so it's just pure somebody holding the throttle stick. There's only so much that you can get out of that. We found that feeding it consistently really, really drastically improved the accuracy. For the most part, the balls were tracking straight, but the biggest thing that we got out of it was that top spin was a lot better with these balls than bottom spin at getting them to drop into the hopper. So traditionally in first, you want backspin on your balls because you want them to fly kind of flat and straight, and maybe hit a backboard and drop into a bucket. There's no backboard this year, so we took both prototypes and we could flip them around to play with that, and that was one of the big revelations we had.
So why do you guys think that the top spin's helping? Like, what's the I don't want to get too sciencey necessarily, but what's the science behind that?
It's basic rotating cylinder lift equation. So any of you that are interested in fundamental aerodynamics, this is a really nifty little problem that applies Bernoulli. And the Bernoulli
What
principle.
would you guys in Seattle know about aerodynamics anyway?
I mean, I do work for Boeing. I have an aero degree. I may or may not know what I'm talking about. But if the ball is spinning with the bottom side forward while it's in flight, it's going to get downward lift from that. and if it's traveling with the top moving forward, it'll get upward lift. A lot of you are familiar with the explanation of lift, where the air is moving faster over the top than the bottom. That's not entirely true for wings. But it's in a roundabout way, it's true. But with the balls, you're getting essentially the same effect. As if the top of the ball is moving faster into the wind relative to the center of mass of the ball, then it's like the top of the wing. It's going to give lift in that direction. So top spin will make the ball, backspin will make the ball want to go straight, and top spin will make the ball want to go down. I think I have that right. Anyways, the upshot of it is, and then keep in mind that all of that gets thrown out the window when you put holes in the ball.
Right.
So
let's talk about so we've talked about the Stalker Parrot here and how you've done with the shooting there. Let's talk about the other aspects to the robot. We saw a interesting little gear mechanism that seems unique from the rest of the check-in teams. Do you guys want to go on about that a little bit?
Sure.
I was not in.
None of these guys were on that group.
But,
I was partially on that group.
Well, Maura, why don't you tell us what the basis of it?
Yeah.
Oh yeah, wait, this kind of grabber?
Yeah, the blue wheels.
Oh yeah. Well, the purpose of that was, of course, get the gear and also lock it in place, so we are able to just bring it up, release, and back up. It would allow us to pick it up off the ground easily, and even if we're zooming across the field, we'll still be able to hold on to it.
So is the idea then for your gear mechanism that you would have these claws that would bring the gear into the robot, bring the gear into itself, and secure it securely, and then rotate up? So 2 degrees of freedom plus a rotation, or 1 degree of freedom plus a rotation.
Yep.
Yep.
Okay. So what led you down that path? Why did you go that direction as opposed to what a lot of teams have done with the passive gear manipulators?
Well, it didn't actually make the final cut. It was the first
Yeah.
prototype we tried, and we really liked it, but it was too big for the robot.
Okay.
The smaller version, it locked on, but it wasn't as secure as the bigger version. I wish we could keep the bigger version, though.
Yeah.
It worked well.
It worked really well. The main problem was just how far outside of the chassis you had to extend, and with the rules this year, that cuts into your chassis size.
Right.
And so we ended up going with a slightly different mechanism that I don't even think was shown in the video, because we tried that one last. We didn't have any video of it for the recap.
Okay.
But
So what's the basis on how that works?
It's very similar to what a couple of the other, I think Spectrum has something similar, and Bob had something similar as well, with the top roller and the plate. And we ended up going with that basically for space reasons. It wasn't the best performing, but it wasn't bad enough to not make the cut.
Okay.
And it was just small.
Cool. So we saw some stuff you guys were doing with like the hopper and sort of like what I should say, the ball, the fuel. What'd you guys call it? The fuel cell or the
Fuel
fuel
tank.
fuel
We
tank?
had
or a ball pit, whichever you prefer.
We had an argument about this, and we just decided, you know what? Let's call it fuel tank.
Okay. So fuel tank it is. I won't reignite that argument. What have you guys discovered so far in the build season with that?
So we tried a number of different designs using wood and cardboard, as you saw in the video. First, we kind of worked on how are we going to feed it into the shooter. We worked on a bunch of different designs and different widths. And then later, we were working on seeing how it was going to integrate into getting balls from the hopper. So there was a ton of iteration there, and I'm really not sure if we've nailed it down because I didn't see the last part of that prototyping, unfortunately. But
Okay.
and we found out a lot of things about collecting balls and kind of draining them. So
Very good. So what's the as we sort of wrap up, what's the plan going forward? What's your next steps?
Talk about
Are you going to continue prototyping, or are you almost done, or what's going on?
yeah, so right now we're working on Party Stalker, getting that ready to kind of test out and see what we can do with that. We're working on CAD. and we're working on developing code for Party Stalker as well to see, so that the coders kind of have a test base that they can, oh yeah, more can talk about that too.
Yeah.
Ooh, wait, no?
Go ahead.
Yeah, go ahead. Yes. Yes.
Sorry.
We'll end the show in a few minutes, so hopefully now it would work. Yes.
Well, we decided that we were going to be using vision and grip and a
Kangaroo.
miniature kangaroo PC. There was a discussion about this with one of our program mentors who's not here today, and it would be better just to have that instead of like a giant PC on the robot.
Okay, cool. That makes a lot of sense. I've seen those and worked with those a little bit before, and they tend to do this kind of a task really well. All right, so we've got one question from the chat. We're going to show up onto the screen right now. We want to hear what you guys have to say about it. So the question is, as we put it up on screen, can you talk a little bit about your priorities during a normal match? So you mentioned that you're going to do all of these different things. What does a normal match look for you guys?
It's kind of interesting because a normal match maybe be, well, each match might be a little bit different. We're really heavily prioritizing gears on this robot, but we want to make sure that we can secure that first ranking point. We think the fuel ranking point is going to be a little bit easier. So hopefully we'll mostly be able to leave the fuel to our partners and run gears most of the match. But we want to have the capability of doing that fuel as well.
All right, cool. Well, it's good to be flexible, especially if you can't necessarily be dominant in one thing. It's good to have a little bit of everything, especially with this game. So very cool. Well, everybody, thank you for watching. 5803 Apex, thank you guys for joining us this evening. That's going to wrap up the show for tonight. We've had 6 great teams come on, and we're really excited to see what everybody's going to do next week. And as we move as we sort of finish up prototyping and move into the design, manufacture, and build of the real robots as we move ourselves toward week 3 of 7. So make sure you tune in next week here on RoboSports Network, 7 o'clock Eastern every Tuesday is when check-in is. So we hope you enjoyed the show, and we hope to see you next week. So Apex, have a good night, and everybody else watching live at home, we hope you have a good night as well. So thank you.